Okay, another day on multiplying polynomials today. Yesterday, we really just focused on what happens when we have a monomial multiplied by a polynomial. Today, we're going to kick it up a little bit more and have polynomials multiplied together that aren't necessarily monomials. Just to warm us up here, again, something you're going to see later on. What you need to do is find the shaded area. Okay, see what you can do. Pause your video. So if you were going to find the shaded area on this one, you'd have to do the area of the big rectangle, right? And subtract the area of that small white rectangle. So length times width for each of them, right? So to find the area of the big one, we'd want to do 10 meters times 12 meters. So that would be 10 times 12. And then I would want to subtract the area of this little one, which would be 7 meters times 2 meters, right? So 10 times 12 would be 120 meters squared. 120 minus 7 times 2 is 14. So the shaded area here would be 120 minus 14, which would give me 106 meters squared. So just remember, to find a shaded area, something like that, where you'd have to find the bigger part minus the smaller part. It'll come up later on. Okay, so let's think about what we did yesterday. Yesterday we did a lot of distributing, and you have done distributing for so long that hopefully that was all pretty common to you. The only thing is you just got to watch those exponent properties, right? So today we're going to distribute again, but I'm not just going to have one monomial on the outside. So notice on this one, I have a binomial times a trinomial. Now I want to take everything in that first binomial and multiply it by everything in the second trinomial. When I just had a monomial out front, one thing, I took that one thing and multiplied it by everything in the other parentheses. So when I have two things, the idea is the same, but this time I want to make sure that I just first take the first term of my binomial and multiply it by everything in my trinomial. And then I will take the second term of my binomial and multiply it by everything in my trinomial. Okay, so let's start with the x. So I'm just going to distribute the x to start with. So x to the first times x to the third is x to the fourth. X to the first times 4x squared gives me 4x to the third. X to the first times negative x to the first, remember I'm multiplying, would be negative x squared, right? This is really like a -1, so -1 x to the first times x to the first is x to the second. Watch that. That's a common mistake right there, okay? Now, I'm not done. So yesterday, that's where we would have been finished, right? But now I have two terms. So now I'm going to take this 3, and I'm going to distribute that to everything. So 3 times x to the third is 3x to the third. Now here again, you could link a whole big long chain, or like we do in adding, I lined up my like terms. So that'll be 3x to the third. Then I'm going to distribute the 3 to the 4x squared, so I'd get plus 12x squared. And then distribute the 3 here, I get negative 3x. So same idea, you just have to do more distributing. If you have more than one term out in front, you distribute all of those terms. And then you definitely have to make sure that you combine your like terms here, right? So nothing to combine the x to the fourth with, it stays put. 4x to the third plus 3x to the third is 7x to the third. Negative x squared plus 12x squared, 11x squared. Nothing to combine the negative 3x with. So it stays how it is. And there's the final answer. Double check that you're writing in standard form. 4, 3, 2, 1. Yes, we are good to go. All right, so take a look at this one. I have a trinomial times a binomial. Same idea, right? Take that first term in your first parentheses, distribute it to everything in the second. 3b squared times 5b to the first would give me 15b to the third, right? Watch those exponent properties. 3b to the second times negative 6, negative 18b to the second. Now I'm going to take my next term and distribute it. Negative 2b times 5b, negative 2b to the first times 5b to the first is negative 10b to the second. Watch that one, right? Those are the easiest ones to goof up for some reason. Negative 2b times negative 6 is positive 12b. But I'm not done. I had 3 terms to distribute on this one. I still have to do this 5, right? So 5 times 5b gives me 25b. 5 times negative 6 gives me negative 30. All right, and then I'm going to take and add up all of those parts. 15b to the third, nothing to combine with, stays how it is. I have negative 18b squared and negative 10b squared gives me negative 28b squared. 12b and 25b, I get 27b, and nothing to combine the negative 30 with. 3, 2, 1, 0, my terms are in degree order, so I'm in standard form. Do you see how lining up those like terms really helps as you go? Again, you don't have to. You can write them all down in a chain and just find your like terms. That would be fine as well. Big idea here, take every term in your first parentheses and multiply it to every term in your second parentheses. Distribute, distribute, distribute. Okay, so now let's just see, okay, here I have a binomial times a binomial. I will be honest with you, this is the most common polynomial multiplying you will see. A binomial times a binomial, okay? But it's exactly the same as what you've been doing. Take that first term and distribute it to everything in the second term, okay? Or the second parentheses. So 6y squared times 3y gives me 18y to the third. And then I have 6y squared times 5 gives me 30y squared. Now I take my second term. I get negative 4 times 3y is negative 12y. I have negative 4 times 5 gives me negative 20. Now I just wrote that in order because I just wanted to show you what it would look like. But also notice in this one, no like terms to combine. So that is our final answer, and it's written in standard form. Now, since a binomial times a binomial is the most common type of multiplying of polynomials that you will see, it does have a special name. It's really just double distribute, right? But it has a special name called FOIL. F-O-I-L. All that FOIL is a way to keep track of all of your distributing. You have to distribute 4 times when you're doing a binomial times a binomial, and so each of those letters is one of your distributing, and that's it. F stands for first terms. Notice when I distributed the first time, I did the first term in each parentheses multiplied together. O stands for outsides. Oh, sorry, my pen's giving me a hard time. Outsides. Whoops, I don't need another O. My second distribute was the 2 on the outsides of those parentheses. I stands for inside. The third distributing I did were the 2 on the inside of the parentheses. L stands for last. My last distributing was my last terms in each of my sets of parentheses. FOIL is just binomial times binomial. Now, you don't have to think of it as FOIL. You can think of it as distribute, 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 distribute. That's perfectly fine. But like I said, since that is the most common type of multiplying polynomials, we give it a special name. A lot of times you'll hear your teacher say, how do we multiply these? You use FOIL. It's just multiplying and distributing, right? But you will hear it next year in high school or the year after, depending on what grade you're in. But it is just one of those things that math people have used and come up with a name for because we use it so often. All right, let's take a look at number 4. A minus 4 times A plus 4. This is a binomial times a binomial again. So you can think of it as distributing or you can think of it as FOIL. It's up to you. First terms, A times A is a squared. Be careful, that's a common one to goof up. A to the first, a to the first, a to the second. Okay, outsides, a to the first times 4 gives me 4a. Insides, negative 4 times a is negative 4a. And lasts, negative 4 times positive 4 is negative 16. So there I did my foiling. However, I do have some like terms here. Positive 4a, negative 4a. Oh boy, those cancel out. I'm left with a squared minus 16. Huh. Well, that was interesting. We haven't really had things cancel out before. Very strange. Take a look at how that started. A minus 4 times a plus 4. That's a special thing. This is what we call the difference of two squares. Look at my answer. I have the difference, it's subtraction. A squared is a perfect square. 16 is a perfect square. That's what we mean by the difference of two squares, or in other words, dots, right? D-O-T-S, dots. And when we see that, we can actually use this shortcut. So if you see that you have a plus b times a minus b, right? That's what our original problem looked like. A plus 4 times a minus 4. A minus 4 times a plus 4. Exactly the same terms, but one was a plus inside and one was a minus. When you see that, what's going to happen every single time is that middle two terms are going to cancel out, and you'll just be left with a squared minus b squared, right? Or in other words, you'll take those first terms, it's the same thing, multiply it by itself. Take the second terms, it's the same thing, multiply it by itself, but it will always be subtracting in between. So here's what I mean by using that shortcut. So I look at number 5. I see 2x plus 5 times 2x minus 5. A plus b times a minus b. That's dots right there. That's dots. I could do all the foiling, I could do all that distributing, and the two will cancel out in the middle, or I could use my shortcut. And I could say, okay, let's do that first term times itself. What's 2x times 2x? 4x squared. I could do that second term times itself. What's 5 times 5? 25. And I know that it has to be subtraction. It's the difference of two terms. You can also think of it as what's 5 times negative 5. But remember, this only works, you can only skip that distributing step, is when you have the difference of two squares, which is a plus b times a minus b. Otherwise, you have to do all the FOIL. Could I have done all the FOIL on this one? Yeah, sure. If you're scared of using a shortcut, you don't have to use a shortcut. You can do all the distributing and you'll get it right every time. But some people are ready for some shortcuts, and in that case, you can use it. Okay, what about this one? A plus 5 squared. Now, the first time we see this, it's very common for people want to distribute and get a squared plus 25. But you need to have a warning on that one. What does a plus 5 squared really mean? It really means a plus 5 times a plus 5, right? It means whatever is squared is that thing times itself. Now let's see what happens when I FOIL this. A times a gives me a squared. A times 5 gives me 5a. A times 5 times a gives me 5a. 5 times 5 gives me 25. I do have some like terms here. I'm going to combine these. Notice they're both positive 5a this time. They do not cancel out. This is not dots, right? Not dots. So I will get a squared plus 10a plus 25. That's the correct answer. When I multiply everything out, no shortcuts, I get a trinomial answer. I have those middle terms that don't cancel out. They have to add together. So this one is absolutely a no deal. Now, you're probably like, but Miss Creeville, I know that back in Unit 4, when I had an exponent outside of parentheses, I distributed the exponent. But here's what's different. In this one, I have a plus sign in between. If you remember, that exponent property was the power of a product or a quotient. In this case, I don't just have multiplying or dividing inside. And that's the difference. If that was one term in there, 5a, then you could distribute your exponent to both parts. But since I have two or more terms, I cannot distribute my exponent. Can't distribute the exponent with two or more terms. Okay, so there are some times when you can distribute an exponent, and that's when there's only multiplying or dividing inside the parentheses. If that is one term, you distribute your exponent to everything inside. If you have two terms or anything else, if there's two or more terms, you can never distribute your exponent. Okay, so what you'd have to do is like we did over here with all of our work, where we write those parentheses out and then use your FOIL or your distributing. So if I look at number 7 now, this is really 2x minus 5y times 2x minus 5y. And also notice, we had a shortcut we could use for dots. This is not dots, they're both minus. These two parentheses are exactly the same, not one plus and one minus. And so that's why we can't use that dots shortcut in this case. Instead, we use FOIL. 2x times 2x is 4x squared. 2x times negative 5y is negative 10y. Negative 5y times 2x is negative 10. Oh, excuse me. I apologize. I wasn't really paying attention here. 4x squared, and then 2x times negative 5y, should be negative 10xy, right? I apologize on that last one. Now I'm going to do negative 5y times 2x gives me negative 10. Now you could write yx, xy, both the same things, right? I tend to write my variables in alphabetical order, so I'm going to say xy for both of them. Negative 5y times negative 5y is plus 25y squared. Oh, I ran out of room there. Let me scooch this over a little bit. There we go. Okay. Now, no matter what order you wrote your two variables in the middle there, those are like terms, whether it's xy or yx. Those are like terms because they have the same variables with the same exponents. So I do need to combine those. So I get 4x squared minus 20xy plus 25y squared. All right. So we've cleared up that we don't want to distribute the exponent, but I don't know if you're noticing this, but there is a shortcut that goes along when we have this binomial squared. We had a shortcut when we had dots. When one was plus and one was minus, we had a shortcut we could take because it was the same thing happening every time. Same thing here. When I have a binomial squared, I have a pattern going on. So this binomial squared shortcut would be, if I have a plus b squared, it'll give me a squared plus 2ab plus b squared. If you look back at our final answer, the first term is the first term squared. A squared. 2x squared is 4x squared, right? The last term is the second term squared. 5 squared is 25. 5y, negative 5y in parentheses squared is 25y squared, right? The middle term was a times b, so you take these two terms and multiply them together and then double it. Now this is definitely a trickier shortcut to use. And many people don't use this shortcut because they're just not comfortable with it, and that's okay. But I put this problem here to practice just so you could see how to use it. So I see that clearly I have a binomial squared here, right? So what I could do to use my shortcut, I don't have to write all the multiplying out. I don't have to rewrite 3x minus 2 times 3x minus 2. I'm going to take my first term and square it. 3x squared is 9x squared, right? 3x in parentheses squared is 9x squared. My last term is going to be negative 2 squared, which is positive 4. All right, now my middle term, I'm going to multiply these two together. 3x times negative 2 gives me negative 6x, and then I'm going to double it. So it'll be negative 12x. And there is my answer. So again, shortcuts are shortcuts. Could you write this out just like we did on the last two and double check and make sure and get the right answer every time? Absolutely. If you are feeling confident in some shortcuts though, you want to save yourself some work, you can do it. Just make sure that you can use it properly and you know when to use it. So we have two shortcuts now, bin squared, and then dots was right up there before that. Okay, we did a lot of other stuff though. We did FOIL, we did distribute. So here's some situations again where you might see that interesting multiplying of polynomials. So here, just like our warm-up, we want to find the area of the shaded region. But this time, I have polynomials. So just like the warm-up, I'd want to do the area of the big minus the area of the small. The big one has dimensions 10 times 8, so the area of the big one would be 8 times 10, 10 times 8, however you want to think of it. The small one has 3x and 2x, so my area of my small one will be 3x times 2x. 8 times 10 is 80, minus 3x times 2x, right? Those are both monomials, so all I have to do is multiply. 3 times 2 is 6. X to the first times x to the first is x squared. Be careful on that one, right? So I have 80 minus x squared. There's my expression for the area of the shaded region. Now that's not in standard form, so if we want to really be specific, I suppose we should write negative 6x squared plus 80 as our final answer, but you get the idea. Okay, now here's a more complicated way that we would see it, and this would be a really true way that you would see your multiplying of your polynomials when they're not just monomials. So this shaded area represents a deck around a swimming pool, and the deck extends 4 feet from the pool on all sides. And it's kind of broken down. We want to find the area of just the deck. Just the shaded area, right? So same idea here. I want to find the shaded area. But it breaks it down into parts. So really if we think about it, this is my pool, right? It says that this shaded area is the deck around the swimming pool, and it extends 4 feet from the pool on all sides. So there's 4 feet, there's 4 feet, here's 4 feet, here's 4 feet, right? Now, if I just wanted to find the, an expression for the area of the pool, so here's the pool, right? I have 4x times x. This is exactly like the last problem that we did. All right, so I have x times 4x, which equals 4x squared. X to the first times x to the first is x to the second. Okay, now it's saying find the area of the deck and the pool, meaning the big, right? If we're trying to find the shaded area, I want to find the area of the whole big thing minus the small one to get the shaded area. So this would really be area of the big minus area of the pool, right? So what they're asking for in part B is the area of the big. Oh, we don't have the dimensions of the big. We gotta figure that out. Okay. Well, let's see. I know that this amount is x, right? And I know that this part here is 4. I can't see that very well. Let me try a different color. This amount here is 4. This amount here is 4. So if x is in the middle, 4 on the top, 4 on the bottom, that must mean that this whole side, x, well, would really kind of be 4 plus x plus 4. But I really want to write that as x plus 8, right? Same kind of thing down at the bottom, or at the top, however you want to think of it. This whole thing is 4x, right? But I have 4 on this side, and I have 4 on this side. So this whole side, I'm going to run out of room on the top, so I'm just going to write it on the bottom. This whole side would be 4 plus x plus 4. Really, I want to write that as x plus 8. Oops, sorry. I apologize. 4 plus 4x plus 4. So this would be 4x plus 8. So there are the two things that I want to, multiply together to find the area of the big. The area of the big would be x plus 8 times 4x plus 8. Now it does say to simplify this, so I do need to actually do my foiling, right? It says simplified, so here's x times 4x gives me 4x squared. X times 8, 8x. 8 times 4x, 32x. 8 times 8, 64. And then if I combine my like terms, I would get 4x squared plus 40x plus 64. That's the area of the big. Now, it wants to find the shaded area here at the end. The area of the deck is the shaded area, which equals the area of the big minus the area of the pool, right? So the area of the big was the 4x squared plus 40x plus 64 minus the area of the pool, which was 4x squared. Oh, well, 4x squared minus 4x squared will cancel out, so the area of the pool is 40x plus 64. Excuse me, area of the deck, the shaded area, is 40x plus 64. So that's about as complicated as it gets, where you had to find your own expressions for the big one, but the idea was the same. It's all that shaded area idea, right? Find the area of the big one minus the area of the small one. Here I had to understand that I had to add 4 on both sides to the little one to get my big one. But the idea is the same. Okay, so just remember, if you're multiplying polynomials, distribute. However many terms the first one has, distribute each one to however many terms the second one has. If it's a binomial times a binomial, we call it FOIL, but it's still just distributing. Combine those like terms, write your answer in standard form, right? And then just remember we have a couple of shortcuts, dots and bin squared. If you recognize it, if you're comfortable with it, you can use it, but you definitely don't have to use those shortcuts.